Let's solve this differential equation. We have x squared plus 2 times of dx equals x plus 3 times of sine y cos y dy. So this can be solved using the variables separable method. In this method, we have to separate all x terms to one side and all y terms to another side, and then integrate and find the solution. So let's do that. So the first step in doing this is we have to separate the x terms to one side and y terms to the other side. So first, I'm going to divide both sides by x plus 3. Since I have this x plus 3 term multiplied with the y terms, that is sine y, cos y, and dy, I first divide by x plus 3. So when I do that, I'll be getting x squared plus 2 over x plus 3 times of dx equals sine y cos y dy. Now looks like we have separated the variables, so we can go ahead and integrate it. Before I integrate this, I rewrite this in the form such that I have the y terms on the left side and the x terms on the right side. So I'm just going to interchange, that is all this should come over here, all this term should go over here. So which means I can write down this as sine y cos y dy. Basically, I interchange the x and y variables to the other sides. So this will be x squared plus 2 over x plus 3 times of dx. Now the variables are separated, so we can integrate both sides. So I put the integration symbol. Uh, to integrate this left side, I'm going to use the trigonometric identity. So that is, we know the trigonometric identity, that is a double angle identity, sine of 2x. This is equal to 2 sine x cos x. So from this, I can solve for only this sine x and cos x. And when I do that, I have to divide both sides by 2. So sine x cos x is equal to sine of 2x divided by 2. So if we can look at here, we have the same trigonometric identity in the same form. However, only the variable is different. So we can replace the sine y cos y as sine of 2y. I'm going to do that. So I can write down this as sine 2y over 2 dy. This is equal to x squared plus 2 over x plus 3 dx. Let's do the integration on both sides. To integrate the left side, I can factor out the half using the constant multiple rule. So I factor the half and then I integrate only the sine of 2y dy. And to do the integration on the right side terms, we basically have to do the long division so that we could split this rational function as a sum of quotient and the remainder or the another rational function. So we will do that. I'm going to just put the terms as it is as of now. So this is x squared plus 3 over x plus 3 dx. Let's integrate this left side. So we have integration of sine 2y is equivalent to negative cos 2y. And then when we apply the chain rule, we have to divide the 2y. We have to find the derivative of 2y and divide that coefficient. That is, we have to put it under in the denominator. So it is negative cos 2y divided by 2. This is the integration of sine 2y. And this is equal to, let's do the long division over here. So we have x squared plus 2 divided by x plus 3. So I'm writing this over here. So first we take the first term or the highest terms of each of the terms, the divisor and the dividend. We have this x over here. So we then do x squared by x, and this gives x. So I put the x over here. I then multiply this x with this divisor, that is x plus 3. So this will give x times of x is x squared. I put below the x squared. Then 3 times of x is 3x. So I can put it here. In fact, I can just move this to a little bit. Sorry about it. I'm going to move this to, or I could just probably erase this. And since I don't have the x term, I put this as 0x plus 2. Now I have to do the subtraction. So I change the signs. X squared minus s squared will become 0. And this will be 0x minus 3x is negative 3x. We bring this term. So therefore this becomes negative 3x plus 2. Once again, we take the first terms of each of the divisor and the dividend. So we have to do the division. Negative 3x divided by x. So this gives negative 3. So I put the negative 3 here and then multiply this negative 3 with both the terms of the divisor. So negative 3 times of x is negative 3x, and negative 3 times of positive 3 is negative 9. Now we have to do the subtraction once again. So we can change the sign like this. So we have negative 3x, positive 3x will get cancelled, it will become 0, and positive 2 plus positive 9 is 11. So this is the remainder, and this is the quotient, which means we can write this rational function, that is x squared plus 2 over x plus 3. This could be written as the quotient, which is this is our quotient. We should not ignore the x. So we have the quotient as x minus 3. I'm going to write down this quotient first, plus the remainder over the divisor. The remainder is 11. So I put the 11 as the remainder over the divisor. X plus 3 is the divisor. So we have converted the rational function as a sum of a polynomial with another rational function, which means we can substitute into our original integral and continue the integration. So I'm going to move this over here. Maybe I could just shrink this a little bit. So I think this is not required. So let me remove this. Now let me put this integration symbol, because we are integrating. So this is equal to integration of dx. And this side we have already integrated. So this is going to result in negative cos 2y over 4. And this is equal to, now we have this two terms inside the integral. So we can write this integral as sum of two integrals as x minus 3 times of dx plus 11 over x plus 3 integral dx. So this is equal to, we have negative cos 2y on the left side over 4. And now we can apply the power rule of integration to integrate the terms x and negative 3. Integration of x is, when you apply the power rule, it will be x raised to the power of 1 plus 1, because we have the power 1 here. So the powers will get added. So x raised to the power of 1 plus 1 is 2 over the 2. And then negative 3 times of integration of 3 or a constant is just 1. And then we put this plus, we have to integrate the 11 over x plus 3. We can first to factor the 11 out of the integral, and then we will have only the 1 over x plus 3. So I put like this, which means we have to integrate only the 1 over x plus 3. So we using the standard integration formula, this is natural logarithm of x plus 3, and then we put the constant of integration c. So we now have integrated this. Let's see if we can further simplify. I'm going to multiply both sides by this 4, in fact by negative 4, so that I will have a positive quantity on the right side. So I will have cos of 2y, this is equal to negative 4 times of x squared by 2, and then I have this minus 3 times of negative 4 x plus this is negative 4 times of 11 natural logarithm of x plus 3 absolute value plus negative 4 times of c. So let's continue the simplification. We will have cos 2y equals this negative 4 will get cancelled with the positive 2 as negative 2 times, and this will become negative 3 negative 4 multiply, you get 12, and negative 4 times of 11 is negative 44, and negative 4 times of c itself is a constant, so you can just put this as another constant, capital C. So let's do this. So this is going to be negative 2x squared, positive 12x, negative 44 natural logarithm of x plus 3 plus c. We could leave our answer either in this form, or in fact we can take the cos inverse and then solve only for the y. So this could also be considered as an answer, and in case if we have to give it in a different form, we take the cos inverse on both sides, so then we will get 2y equals cos inverse of whatever we have on the right side, that is cos inverse of negative 2x squared plus 12x minus 44 times of natural logarithm of x plus 3 absolute value plus c, and then since we want to solve for y, we can divide by 2 on both sides, so therefore y equals all this quantity on the right side over 2. So either this could be the answer or this could also be the answer. Both could be considered as the answer for this question.